Hi, my name is Jesseline. This is still going on with our transformations, and this is about reflections. So let's talk about reflections. So a reflection is going to, the shape of the size, or the shape is not going to change, or the size of the shape isn't, but it's going to be reflected. It's kind of like looking in the mirror. It's kind of looking at the opposite. You're looking at a mirror, it's a reflection. So first of all, let's talk about the line of reflection. A lot of times the line of reflection is either the y-axis or the x-axis, and that will be a lot of your problems. But sometimes they might draw a line and be like, that's our line of reflection. So whatever your line of reflection is what you want to use to make that the center of, is your mirror. That's your mirror. Your line of your reflection is your mirror. That's the center of your reflection. So the distance of that figure from the line of reflection has to match the other side. Okay, and for example, so and these have rules as well. So let's talk about the rules, and then I'll give you an example that doesn't use the x or y axis as a line of reflection. So here's the rule for reflecting over the x-axis. So reflecting over the x-axis, the rule becomes xy. And this is kind of weird because you would think that reflecting over the x-axis, the x-coordinate would change, but it's actually opposite. The y-coordinate changes. The y-coordinate becomes opposite. Okay, so let's do that. Let's reflect over the x-axis. I will draw a triangle. Oh, I'm drawing a little triangle. Okay, so that's A, that's B, and this is C. Okay, so I don't know why I drew the prime things. We don't need those because that's not the image. This is the original. So this is ABC. So A is 1, 2, 3, 4, 5, -5, -2. So that's A. B is -4. 1, 2, 3, 4, -4, -4. And C is -6, -4. And so we're going to apply this rule where reflecting over the x-axis, the y becomes its opposite. So the x doesn't change, and then the y becomes opposite. So -2, its opposite is +2. The x doesn't change, but the opposite of the y, -4, becomes +4. And the x doesn't change again, but the opposite of the y, -4, becomes +4. So now we can take these and just graph them, and we will reflect over the x-axis here, the horizontal line. So -5, 2, so -5, 2 becomes right there, so that's A prime. B becomes -4, 4, so -4, 4, so B prime. And C becomes -6, 4. So -6, 4. And that's C prime. And you see that we have our triangle, and it's reflected. Now we use the rule, but if you don't want to use the rule, all you have to do is determine your line of reflection, which is our x. So this is our x-axis. If you notice, A is 2 away, so you would go up that same line and just do 2 away and graph it there. C, 1, 2, 3, 4, continue going up. Once you hit your line of reflection, go 4 more, 1, 2, 3, 4, and then you do the C. B is also 1, 2, 3, 4, but continue going up that line, 1, 2, 3, 4. So the coordinate points are the same distance away on each, on the line of reflection, on each side of the line of reflection. Okay? Let's do the same thing, and let's do that image, and let's reflect it over the y-axis. Let's reflect the original image. So the y-axis, here is the rule. I bet you know it, because in the x-axis, the y changed. So if we're flipping over the y-axis, the x is going to change. So the x becomes opposite, and the y stays the same. So again, A is -5, -2. B was -4, -4. And C was -6, -4. So now we're going to apply this rule, the y-axis rule, where the x changes and the y stays the same. So the opposite of x, so the opposite of -5 is 5. The y stays the same, -2. The opposite of -4 is 4, and the y stays the same. And then the opposite of -6 is 6, and the y stays the same. So now we can take these and graph it, and we will have flipped it over the y-axis. So 5, -2, 1, 2, 3, 4, 5, -2, so that's A prime prime. 4, -4, so 4, 1, 2, 3, 4, that's B prime prime. And then C is 6, -4, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, uh-oh. That's C prime prime. I should have listed my B prime prime over here. Okay, so here is my triangle. And again, we can check it by seeing if it's the same distance from the line of reflection, which is the y-axis. So A is 1, 2, 3, 4, 5. Keep going on that line. 1, 2, 3, 4, 5. Works out. C is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And B is 1, 2, 3, 4. 1, 2, 3, 4. So they're the same distance from the line of reflection. So we done it. Okay, let's just talk about reflecting over a line that's not the x or y axis. So that doesn't necessarily have a rule, okay? But you can use what you know about the distance to say, so let's make this my line of reflection, okay? I'm making that my line of reflection. And I'm drawing my little triangle here, okay? So my A, B, C. And the line of reflection, all you have to do is count again. So it's 1, 2 away from the line of reflection. So 1, 2, so that would be A prime. C is 1, 2, 3, 4. Keep going up that line. 1, 2, 3, 4. That'd be my C prime. B is 1, 2, 3, 4. Keep going up that line. 1, 2, 3, 4. B prime. And then I draw my little triangle, and we have it. So you can do that counting line of reflection, and then you can list the coordinate points. So that is reflection. Hope you enjoyed that video. Thank you for joining. Bye.